Today we will solve any problems from physics, and firstly read exercise, and you can hear with what speed must an electron move so that its momentum is equal to momentum of a photon with a wavelength of 520 nanometers. Okay, we know that is wavelength equal to 520 nanometers. And how we calculate this? Firstly, from exercise we need to find speed. Okay, and solutions these problems. Solutions. Okay, from physics we have a formula P equal to m e v. Okay, here m, it is a mass of electron. Mass of electron. So mass of electron we know 9.1 multiplied by 10 degree minus 31 kilogram. And we know it's v, and we also write the de Broglie wavelength formulas. Okay, if we calculate our equation, we know that wavelengths equal to by h divided by p. Okay, in this formula h is Planck constant, so this is equal to by 6.62 multiplied by 10 minus 33. And how we can we express the momentum of a photon? Okay, P, it is photon. Okay, if we translate these formulas, we find to P photon is equal to by h divided by lambda. Okay, let us equate the right parts of formulas. Mass of electron multiplied by speed, and all of equal to by h divided by lambda. And we can calculate this. We find speed firstly, and if we calculate this by method of подставления, our speed equal to by 1400 meter seconds. So that's all. Thank you very much. Second, our exercise. Now I read it. By how many degrees will a drop of water with a mass of 0.2 gram heat up in 1 second if it absorbs 10 photons every second with a wavelength of 0.75 microns? So and ignore energy losses. Okay, firstly we write what is given. Given is T, given mass, given lambda, and given delta T. Okay, I'm so sorry. Find this. We need to find this. Okay, our T equal to 1 second, M equal to 0.2 gram, and lambda equal to 0.75. and we know that is n equal to from this exercise 10 degrees 10. Okay, if how we solve this? We know so specific amount of head q we can determine by the formula. Okay, our q equal to by c m delta t. Okay, in this formula c is the specific heat capacity of water. Okay, equal to 4200 joule divided by kilogram Celsius. Okay, obviously the total energy of all photons E is equal to the product of the energy of one photon on the number of these protons n. Okay, now I erase this. Okay, now we according our equation, so E equal to by Ne0. According to Planck's formulas, the photon energy proportional to the oscillation frequency V and is defined as follows. Okay, but by these formulas we can write E0 equal to by HV. Okay, in these formulas H is Planck's constant. So this equal to 6.62 multiplied by 10 minus 34 degrees joule seconds. It is known that the oscillation frequency V can be expressed in terms of the speed of light which is equal to 3 multiplied by 10 degree 7 meter second, and the wavelength lambda, so like lambda according to the following formulas. So we know by speed equal to by c divided by lambda, and first we substitute into, then we substitute the obtained into. Okay, then we get E n our also constant from this exercise, all of divided by lambda, and all of equal to by c m lambda. So this all of stay, it's here. Okay, and finally answer equal to by delta t equal to by 3.15 multiply by 10 minus 9 degree, minus 9 degree Celsius. Okay. um, Final exercise from these lessons. For these lessons about ice. Okay, now I read the exercise. The threshold sensitivity of the retina of the human eye to yellow light with a wavelength of 60 nanometers is 1.7 multiplied by 10 minus 80 degree. Okay, how many photons will each second on the retina? Uh, Firstly, we write is given. Given is lambda. Given is lambda. Given is p, and given is t. Our lambda equal to by 60 nanometers. Our p equal to by 1.7 multiplied by 10 minus 80 watt. Okay, I'll write in Russian. And t equal to 1 second. We need to find. Okay, find. I write the right here. Find n. Okay, solute this. Solutions. And solutions of these problems. How is this calculated? So it can be seen that the threshold sensitivity of the eye is expressed in units of power. In this case, the power is the total energy of all protons which fall on the retina per unit of time. So it's fair to write. Okay. Okay, we know that E it's protons, and P is power. Yeah. Okay. We know that is we know this equation P equal to by E divided by T, and obviously the total energy of all protons is equal to the product of the energy of one proton. Assuming all protons are the same by the number of these protons. Okay. And from this equation we can write. We don't translate this. We just we just follow from this equation equal to by n multiplied by E0. According to Planck formula, the proton's energy E proportional to the oscillation's frequency and is defined as follows. Okay, we know by E0 from past exercise, past problems, E equal to by H multiplied by V. In this formula, H is Planck constant, we know, yeah? And equal to by 6.62 multiplied by 10 minus 34 degrees joule second. Okay, it's known that the oscillation frequency can be expressed in terms of the speed of light, and which is equal to 3 multiplied by 10 8 meter second, and the wavelength according to the following formulas. Okay, write this, and we know by our problems, we know about from our problems, our velocity equal to by c divided by lambda. And let us first substitute into the result obtained into and the result obtained after that into formulas. Then we obtain p equal to by n r c divided by lambda t. Okay, from these formulas we express the desired number of protons. Okay, how we find number of protons? Equal to by p lambda t divided by r c. And let's calculate this. The numerical answers was all of equal to by 5.14 degree 14. Okay, and ответ нужно округлить, короче. n равно 6.